Hello again, calculus students. We are looking at 4.3 and 4.4, what the derivatives tell us about the shapes of curves, and what we've been doing is just looking at different functions. So we started with polynomial, and now we're getting ready to look at and analyze a quotient. I did change this, so it depends on when you looked at this sheet. It should be x squared and not x over x squared plus 4. Let's take a look at this. So we're going to start our function. And always keep in mind, we're doing a first derivative test. Ask yourself, what does the first derivative give you? Increasing, decreasing, relative, max, or min. So we're going to take the derivative of this. How do you take the derivative? Quotient rule. So we're going to do low, d high, derivative of that is 2x, minus high, derivative of that is 2x, over the denominator square. And then simplify that. We're going to distribute 2x cubed plus 8x minus 2x cubed over that squared. Just leave that. And then that simplifies to 8x over x squared plus 8. Now we have to set that to 0. We're looking for the zeros, the critical values. And when I set that to 0, you can think about it as kind of cross multiplying. This is our first time setting this to 0, I think. We haven't done one set this to 0. I know you've done it in algebra, but some of your algebra skills are still improving. If I take 8x times 1 is cross multiply. So you take 8x times 1 is equal to that times 0. So that'll give you 8x is equal to 0. You essentially set the numerator equal to 0 and the denominator equal to 0. If you can remember, we're looking for where our critical numbers, and that's where the first derivative is 0 or does not exist. So that's when the denominator is equal to 0. So if I set 8x equal to 0, divide both sides by 8, I get x equals 0. Now this one, x squared plus 4 squared, I would square root both sides here and get x squared plus 4 equals 0. Put a 4 on that side. I'm getting plus or minus square root of negative 4. That's plus or minus 2i. This is not real. So if you noticed that earlier, you can just omit it. There aren't any critical values from that denominator because of that plus 4. This is your only critical value. And remember what I do now. I have my number line, and my number line has the derivative next to it. I keep telling you, please label your number lines. And now we're going to test a value into this derivative to see if it's plus or minus, and that I've chosen. And then we're going to pick something after the 0. So I chose negative 1. I put that in there. Now, as you plug these in, all we're looking for is if it's positive or negative. So what I did is I put in 8 times negative 1, and then I looked at this and I go, oh, I don't care what I put in here. If I square that, add 4, that's positive. If I square that, that's positive. If you want, you can put a value, get a value here. But the point is, this is negative. So I am writing negative here. Now, I'm going to pick something over here, like a 1. F prime of 1, and I did the same thing. I put a 1 here, put a 1 down here, and I got 8 times 1, that's positive, and then down here, 1 squared plus 4, that's 5 squared. I mean, if you really wanted to, you could go that this is 8 over, what would that be, 1 squared, so it's 4, it's 5 squared, 25, 8 25ths. However, all I want to know is that positive or negative, and it is positive. All right, so our first derivative. This means decreasing, negative, and this means the function is increasing. Now, one thing I want to check on, I really should be doing this. What is the domain of this function? I should be thinking about that. I haven't had to because we've dealt with polynomials, and the domain of all polynomials are all real numbers. Okay, so the domain of this one. What x, you know, you might have a trouble if you have a 0 in here, but if I set that to 0, you're not going to get any 0, so the domain is all real numbers. So I'm not concerned about the domain at this point. I just went back. I have to remind myself to look at the domain. Usually I run into it when I start working. Now I've got negative to positive. If this function goes from decreasing to increasing, so I kind of draw a make-believe function, decreasing to increasing. This is a minimum. You see, that's a low point. So that's going to be a local minimum here. If a function goes from decreasing to increasing, and it's defined at 0. That's why I was looking at the domain to see if 0 was okay. Usually it'll come out in the wash, but here's the conclusion. F is decreasing. It's all about F on negative infinity to 0. F is, decreasing on negative infinity to 0. F is increasing on 0 to infinity, and F has a local minimum at 0, 0. I'll be back for the second part of this.